Okay, this video is going to be over the atomic or the periodic table, and I want to use the arrangement of the periodic table to show you how useful and beneficial it is for us in science, especially when we're talking about atoms and how they combine with their valence electrons and things like that. So let's get started, and let's first start at looking at the very next slide, hopefully. There we go. So this is a slide or a view of the periodic table we've been using in class. And first of all, what I want to show you is that we have these group names that associate the column that's right below it. So we have group 1 all the way through group 18. Now the thing about this is atoms are very unstable here, but as we work across the table from left to right, they become more stable. And what I mean by that is that the atoms are gaining electrons in their outer shell, their valence electrons. And as they start to fill up, the atom becomes more satisfied and is not as unstable as it was, as atoms might be in the earlier stages. And so group 1 atoms, these atoms have one valence electron in their outer shell. And if you remember, we've been talking about that. So like, for example, hydrogen, if we ignore the nucleus and we just look at the electrons, so let's say that this is the nucleus, the first ring would have one electron because it only has one ring. And so it only has one electron sitting out there. Well, if we look at lithium, if we look at its nucleus, the first ring will have 2 electrons, and it fills up with 2, so the very next ring only has 1. And how do I know that? It's because of this 3 right here. That 3 tells me it has 3 electrons total. Well, if you remember our rule of 2 and 8, then we remember that the first ring can hold 2, the successive rings can hold 8 electrons to satisfy when it fills up. And so we're kind of looking at that. And so if that's true with group 1, then we can also use that same rule for group 2. That everything in group 2 has 2 valence electrons. So if we were to do beryllium, for example, beryllium, if we look at its nucleus and we go around it, the first ring can hold 2. It has a total of 4 electrons, and so the next ring gets 2. And remember, it would like to have 8, so it's not quite there yet. Now, why this atom and hydrogen, of course, are unstable and the other ones below them are unstable is because it's easier for it to get rid of those 2 electrons than to go find 6 more, for example, for beryllium. 6 more electrons would satisfy its outer shell. And so it's always kind of looking at what would be easier, to give away some electrons or gain some. Now, when we look at the transition metals, which these are the transition metals here, these guys right here, we cannot use the same rule to apply to them. They act a little bit differently. So we're going to ignore those atoms, and we're going to ignore what we're doing with the group numbers. Those numbers will not identify the valence electrons for those atoms. But once we get into these other groups, like group 13, we just look at the 3, and we look at the 4, and the 5, and the 6, and the 7, and the 8. Now remember that 2 and 8 rule that we talked about, the 2 and 8? Well, this atom, or these atoms here in group 18, they have a full outer shell. They are very satisfied, very stable. In fact, we call them noble gases. So they're the noble gas group. And the noble gases, they have a full outer ring. They're not going to combine with themselves or any other atoms. They are completely 100% stable. Now, helium is the only one that's kind of bizarre in this group, and that is because it only has 2 electrons. But remember our rule, 2 and 8, right? I forgot to write the 8 earlier. But the 2 tells me that that's how many electrons fill up the first ring. Well, this helium only has 1 ring. And because it has its 2 electrons sitting there, it is satisfied. So let's draw it a minute. Here's the nucleus. Here's the first ring. The 2 tells me it only has 2 electrons. So when I put those there, that ring becomes full and it's satisfied. It doesn't want to combine with any other atoms. Okay, so that's why group 18 is very, very stable. Okay? So some other things to notice about this periodic table is maybe how do I know that all these atoms have certain numbers of rings? Well, we have a very quick way of identifying that. And the quickest way to identify that is these numbers right here. 1, 2, 3, 4, 5, 6, 7. Now these numbers identify the rows, so as they come across. So we have 7 rows of atoms. And what that number really tells me is that each one of those atoms only has a certain number of rings. And we call these the periods. Now the periods will tell me how many rings there is. We already know that hydrogen has 1 ring. Remember, because we drew it just a minute ago, and we had 1 ring with 1 electron. Helium on the other side, way over here, you remember it had the nucleus with 1 ring, but it had 2 electrons, so it was full. That's why we only have 2 atoms in period 1. We start looking at period 2 now, and lithium, beryllium, and these others over here, boron and carbon and so on, we could actually work about those for just a second. So let's just take this atom lithium. Well, lithium is just right after helium, right? So this lithium atom right here. So lithium has 1 more ring, and if we look, it has 1 more electron. Look what happens to beryllium. It's the next one over. It has 2 rings, but it has another electron. If we look at boron, it has 2 rings, but now it has a total of 5 electrons, so we need to add another one. Carbon, add another one. Nitrogen, add another one. Oxygen, add another one. Fluorine, add another one. And then finally we get to neon, add another one, and the shell is full. So now we go back to period 3 now. Period 3, and we add another ring, and we can do the same thing over again. Add 1, and keep moving over to magnesium, and keep going across, and you're going to keep adding an atom, or an electron to that atom. So that's how that works. So that's a pretty handy way of knowing how many rings do I have, and what exactly is it that makes up the electrons in those rings. Okay, now one thing about it, if you remember our 2 and 8 rule, if we just think about it for a second, this group 1 only had 1 electron in its outer ring. Well, look over here at 17. We circled that 7. So it has 7 in its outer ring. So if we take the 1 right here and we add it to that 7 over there, we get that number 8. Remember our rule? 2 and 8? 2 and 8? So we get those electrons together. They start sharing together. Then we get a very stable system. And so, for example, we can get sodium. We can get chlorine over here to combine up, and we get NaCl, a very stable element. You know, sodium by itself is very reactive in water and around water and things. Chlorine is a poisonous gas. But we combine these 2 guys together because they actually, sodium will give its electron away to chlorine, which we've talked about in class. And because of that, it stabilizes the atoms. Both atoms become ions. Because this sodium gave away an electron, it's now a positive 1. And because chlorine gained an electron, it becomes a negative 1. So we call this an ionic bond. What's cool about that is these 2 substances that were once kind of hazardous or not too nice or very friendly and very unstable, they now become stable. Now they become table salt. And if you notice, table salt has no properties of chlorine and it has no properties of sodium. They are totally different from those things. So when we combine things in a chemical reaction, we get products that have really no identity to the original parts that made them up. So it's really kind of cool how that works. We can use the same rule here. Group 2 has 2 valence electrons, and group 16 has 6. So these guys, 2 plus 6, will combine to give you 8 outer electrons in their valence ring. And so those become very much of things that want to get together again. So you can think of magnesium sulfide, so MgS. Okay? So that is a chemical compound that comes together very easily because it wants to do the very same thing that sodium and chlorine were doing. So it creates those kinds of bonds that help them attract one another. Now, as far as the rest of the periodic table, you just need to remember that this atomic number will always tell me protons. And because these atoms in the periodic table are neutral, then I also have to remember that it will tell me the electrons. So, for example, silicon will have 14 protons, which are in the nucleus. It will be surrounded by 14 electrons, 2 in the first ring, The others are going to build on that with other rings on the outside. And then to find the neutrons, remember that this atomic mass is a total of protons and neutrons added together. And so because of that, all we have to do is round that number. So we round it, and we subtract. So we subtract the atomic number, and we end up with the neutrons. So you always have to remember to subtract for our neutrons. And that was in a previous lesson. If you want to go back and review that, you'll remember that item being talked about in class, and also the YouTube video that is available for that very much discusses that. And I believe that was the introduction to the periodic table. We talked about that. And also I think in drawing atoms, that lesson as well, we discussed that. So that's just kind of a review. Now, everything on the left-hand side of the zigzag line are metals. Now, that's the exception of hydrogen. Hydrogen is actually a gas. And the only reason hydrogen is sitting over there by himself is because he has that one electron sitting in that ring. So he belongs with group 1 elements, okay? Now, everything on this side are nonmetals. Okay, they could be gases. Some of them are liquids. Some of them are just non-metal type substances that are out there. And the items that I'm going to shade right here, these are called metalloids, meaning that they are not quite metal and they are not quite non-metal. They have properties of both things. And so we call those metalloids. Okay? Now there is one atom that's sitting over here on the line that is a metal. And so he doesn't quite follow the rule, and that is aluminum. Aluminum actually is a metal. Now some properties of metals are they conduct electricity, they're ductile, meaning that they can be pounded flat. That's why we use them for coins and things like that. Cans and all that. They're also, that's malleable when they can be pounded flat. Ductile is that they can be stretched into a wire, so that's why we use a lot of these different things in wiring in houses and computers, electronics. They are also have a luster, meaning that they are shiny. One other thing about it is that these atoms that are nonmetals are quite the opposite, that they do not conduct electricity, they're not shiny, they're brittle. You can't pound them flat. They won't be spooled into a wire. So those are the differences between metals and nonmetals. Well, that pretty much covers the lesson for the periodic table. Please review it. I know I erased a lot and redrew a lot, but really, whatever you can do to your periodic table to make it useful for you is what I want you to do. You'll get a blank periodic table every time you take a test or quiz where you need it. So you really got to memorize how to use it. But those are kind of the nuts and bolts, and there may be some other things that I left out. But really, that is a great hit of what you need to know for the periodic table.